Okay, good morning, everyone. My name is Iqbal Gurewal, Technical Support Manager here at CADPoint. Thank you for joining us today for our webinar, Top 10 Tips for Autodesk AEC Collection, Introduction to InfraWorks. In this webinar, we have our technical consultant, Jonathan Brookfield, who will give you an introduction to InfraWorks. Jonathan's going to be focusing on getting started with using InfraWorks to create topographical models to show site context, including road layouts, paths and bridges, etc., plus how to collaborate with other programs such as Civil 3D, Recap Pro and Revit. Just to give you some background about us, CADPoint, we're based in Crowthorne, Berkshire, and are a gold partner with Autodesk Software. We have a team of experts ready to assist you in all aspects of design. We are also partners with some of the most trusted hardware manufacturers in the industry, including NVIDIA, HP, etc. As far as software, as well as software that we do, our team can also offer introductory training for new customers and offer advanced courses for experienced users to help you get more from your software. So without further ado, I'm going to pass you on to Jonathan.
Thanks, Iqbal. Can you see the monitor at the moment?
Yeah, I can see that.
Good stuff. Right, as the webinar will introduce myself, I think we'll just get started. Hello, and welcome to today's webinar on Top 10 Tips for Autodesk AEC Collection, an introduction to InfraWorks. My name is Jonathan Brookfield, and I'm going to start by giving a brief overview of my industry knowledge and experience. I have primarily worked at consultancies, working in the maritime waterways, coastal defence and flood alleviation sectors, predominantly in a civil engineering capacity, although I have experience with mechanical and electrical, geotechnical and environmental aspects of projects. I have an in-depth knowledge of building information modelling, virtual design and construction, and digital transformation. I was a BIM manager when working for a consultancy, whereby I implemented BS 1192 and/or ISO 19650 at project, organisation and client levels. I was the sole technical author for a UK public sector agency's CAD and object standard, containing aspects such as standardisation, both drawings and model deliverables, asset data requirements, and automated verification across the entirety of their frameworks for all stakeholders involved, including consultants, contractors, and internal personnel, to name a few. My core software experience includes 2D and 3D AutoCAD in the earlier part of my career. I was an early adopter of Civil 3D, generally using it for mass paving design, earthworks, linear defence structures, drainage and other utilities modelling, geotechnical and ground investigations, and some road and highways design. I've applied Revit in a less traditional sense, using it for civil structures such as quay walls, river structures including locks, moorings and fish passes, and reinforced concrete modelling and scheduling, rather than for structural engineering or architectural designs. Navisworks for model federation, clash detection, and 4D modelling or construction sequencing, and most recently InfraWorks, which is what we're going to be looking at today. So why InfraWorks? We're currently seeing a transition from traditional 2D drawings and documents towards smart data-heavy 3D models. InfraWorks is primarily tailored towards 3D modelling, with several document or report outputs from the analysis tools. With this move towards 3D modelling, detailed design, construction or operation and maintenance models can be time-consuming to produce, even with automated workflows using tools such as Dynamo. InfraWorks allows users to very quickly produce geometrically realistic models at the conceptual phase of a project to be used as a base for more advanced detailed models. The flexibility and ease of altering InfraWorks models makes it the perfect tool for optioneering. In engineering and construction, we're guilty of producing overly complicated technical drawings early in the project as what has been traditionally done. Not only are drawings time-consuming to alter, only those from a technical background can really understand such documents, leaving scope for mistakes and misinterpretation to take place. InfraWorks makes it so that those from a technical or non-technical background alike can easily understand the proposed design. Finally, taking positives from the previous points, InfraWorks provides a quick and cost-effective stakeholder engagement tool, whether it is sitting down with a client and live altering models, as decisive decisions can be achieved from its visual interactivity to briefing contractors for site inductions or understanding existing environments. Our first tip is on how to create and set up your InfraWorks model using the Model Builder. To start with, click on the Model Builder button. From here, we will now need to identify where in the world our project is situated. This can be almost anywhere in the world except for security sensitive or remote areas. For this example, I'm going to use a part of the UK which I'm familiar with to ensure the model created looks correct. We can switch between the mapping styles, road, aerial and ordnance survey. To select our model extent, we can choose from 4 different options. Select current map extent, draw a rectangle to select an AOI, draw a polygon to select an AOI, or import a polygon to select an AOI. In this example, we're going to simply use the Select Current Map Extent feature. To complete the site location assignment, we need to apply a relevant name or reference to our model before we can click on the Create Model button. Now all we have to do is wait for the Model Builder to buffer. The time varies depending on the size of the model extent. For this example, I'd expect it to take about 5 minutes or so. An email will then be sent to the user to notify them of its completion. When we go back into InfraWorks, we can see the model has now appeared in our list. We now need to decide where we would like to store the model. As an advocate for BIM 360, I'd always choose the cloud, but you can save it locally or to a server. Once a suitable location has been identified, BIM 360 will then download the model. In my experience, this is usually a quick process. And there you have it, a model ready for you to start optioneering and designing. You can already start to determine how easy InfraWorks is to use. In our second tip, we're going to be looking at the different types of features and elements you can add to your InfraWorks model. For starters, let's take a brief look at the model's properties. Here, we need to ensure the coordinate system we are using is correct. As I'm working within the UK, I'm going to set this to OSGB 1936 National Grid. For those who are experienced in working with coordinates, we can see below the numbers have changed to a more familiar 6-digit number to 2 decimal places. Additionally, although I'm not going to alter them, we can change the terrain settings and set the model time. When looking at road design, we can set the applicable design standard. Again, as I'm working in the UK, I'm going to select the Design Manual for Road and Bridges metric option. We can also state which side of the road we want to show vehicles on. As it is currently set to the left-hand side, I'm not going to change this. Finally, we can set the specific country pack we'd like to use in our model. These can be installed via the Autodesk desktop app. I'm now going to quickly demonstrate how you are able to toggle items off and on using surface layers, as this can be quite useful for visualization purposes. As you can see, we can turn all of the transport surfaces off and on. We can repeat this process for any of the water features if we want to omit elements such as canals, rivers and lakes, and be simply left with the background imagery instead. For visualization purposes, we can remove any of the background satellite or mapping imagery for more architecturally or urban planning biased rendered outputs. This gives us a simplistic view of the model's key features. Let's now start adding in some proposed features to our model. We're going to start by connecting two existing roads together by creating a bypass across some fields and a river. To achieve this, we're going to use the component road tool. If we're to use the model data elsewhere, it is a good idea to assign the road with a unique name or identifier. All we do now is click the path for where we want the road to follow, like a polyline. You'll notice that the road alignment follows the contouring of the existing landscape. It will also add any radii required for corners and bends. When we reach a river or other water sources, simply continue using the component road tool. I'll show you what we can do with this later. Finally, InfraWorks lets us simply tie into an existing road. We complete the command by double-clicking with the left button of our mouse. We've now completed a preliminary road model. In real time, this would take a user less than a minute. Now that we have created our road, we can manipulate the model in the horizontal plane by dragging the nodes to how we want it to alter the alignment. Where radii occur, its movement is restricted so that it stays in the confines of what is trafficable. One of the really great features in InfraWorks is being able to amend road elevations to still work with the existing landscape. We can do this by selecting the road and clicking on the profile view icon. We can see here that the road crest is projected as a simple profile line in the longitudinal section. Here, we can amend the elevations by simply dragging the profile nodes up and down. The model alterations are shown live in the InfraWorks model, making this a brilliant feature for design review meetings with relevant stakeholders. In summary, this tool allows us to create roads efficiently in an intuitive and parametric workflow. As we are currently satisfied with the road alignment, we can now create a bridge across the river. We do this by going to Structures and selecting the Bridge tool. To engage the process, we simply need to select a start and end station along the road for where we would like the bridge to occur. Once selected, it takes InfraWorks a moment to buffer the proposed bridge geometry. As you can see, the outcome is quite impressive. A few clicks of the mouse and we have a fully parametric bridge model following a specific region's design codes. Due to its parametric nature, we can amend the number of piers that occur along the structure. As there is a reasonable amount of data to process following each amendment, it does take a moment for InfraWorks to recompute the model. Beyond being able to change the number of piers, we can also change the spacing distance and the rotation of each individual component, depending on the proposed design or existing conditions. The result is quite remarkable. Essentially, we are left with a fully modelled bridge ready for further design. I shall demonstrate the bridge model's interoperability with other software a little bit later. As we have created a component road, we can include additional linear elements such as barriers, additional lanes, fencing, curbs, and so on. As we're on the subject, it is worth explaining the two different types of roads InfraWorks has to offer: component roads and planning roads. Component roads, as described, have the versatility to include additional items like the construction of a civil 3D corridor and would be used for detailed design purposes. Planning roads, however, can instantly change their appearance, whether they're a motorway or a track, with out-of-the-box styles included with InfraWorks. Planning roads are very limited to what you can do with them once created. If required, they can be converted to a component road if the user wishes to further develop them for design purposes or perform any traffic analysis simulations. To add a new element to a component road, we can simply right-click on the feature and select Insert Road Component. Here, we have the option to choose from various elements. You can even make your own library using Autodesk Inventor parts. Like the bridge tool, all we have to do is define a start and end station along the road for where we want the barrier to occur. Once placed, we can manipulate the barrier's extents by dragging the nodes along the road alignment. We now have a barrier along one side of the road where the bridge is situated. We shall repeat the process to include a barrier on the adjacent side. We are now going to include additional features and furniture to create an entourage or further develop the visualization of the proposed design. This will be achieved by going to Environment and selecting the Row of Trees command. Like road creation, the user can simply draw a polyline along the path of where the trees are to occur. This tool doesn't have to be exclusively used for vegetation and can be used with lampposts, bollards, and so on. Once placed, we are able to adjust the density which controls how often the object occurs along the path, as well as changing each individual component's rotation and height. This allows users to take full control of the aesthetics in their InfraWorks model and produce dramatic visualizations for their customers and clients. InfraWorks models and visualizations don't have to be exclusive for end-user or finished asset results. Here, we have an example of how the City Furniture tool can be applied for creating a site compound. You can use the models to identify site compound extents, spatial awareness of plant storage, material storage, facility and welfare location and requirements, and safe walking and distance areas. Examples for how this model can be used could be for scenarios such as inducting contractor personnel before they've even set foot on the site, or for demonstrating the impact of a site compound on the surrounding area for public consultation purposes. Finally, we've added a few more features to our road to enhance the visual impact of the model. I've created hedges and placed lampposts along each side of the road using the Row of Trees command. Additionally, I've included a pavement along one side of the road using the Insert Road Component command. There is also now a set of traffic lights placed at the junction. One aspect you may find with InfraWorks is that a lot of the items are in an American style. This is gradually changing for a more UK and European market by the introduction of regional country packs, as well as the ability for you to custom create model parts in Autodesk Inventor and create your own object libraries. In tip 3, I'm going to show you how to use InfraWorks model information in both Civil 3D and Revit. I'm going to start by exporting the InfraWorks model into a usable format by going to Present, Share and selecting Export IMX. Here, we can decide whether we want the whole model or a segment of the model to be exported. We then need to ensure we're exporting the model using the correct coordinate system. Finally, we must define where the file should be exported to and its file name. Now all we do is click Export and either create a new file or replace an existing one. In our Civil 3D model, all we need to do is go to the InfraWorks tab and select Open Model. We can select the file we exported from InfraWorks in the previous step. You must always ensure the coordinate systems are correct and align with one another. In this case, we're still using OSGB 1936 National Grid. Then, select the object settings file you want to apply to the imported data. This will control the aesthetics of imported InfraWorks models. And finally, select the objects to be imported such as alignments, surfaces, and proposed features. I wouldn't recommend importing everything, as it will prolong the import process in addition to overcrowding the model. As you can see, there are a lot of alignments from all the roads contained in the InfraWorks model, which will be unnecessary and irrelevant to our project, so we shall simply select the items we need. Now we've checked the coordinates and refined our model selection, we can click Open Model. The model elements are now imported as Civil 3D surfaces and alignments, ready for more detailed design and drawing production. We can change the aesthetics of these objects as they are now Civil 3D entities. We can also export our InfraWorks bridge model to Civil 3D by right-clicking on the bridge component, selecting Publish Civil Structures, and either create a new file or update an existing one. This file can be stored in BIM 360 via the Autodesk desktop connector, or alternatively to a local computer or server. This workflow converts the data to a IMX file, which can be read by Civil 3D or Revit. The process for importing the bridge data into Civil 3D is the same as the previous, with the exception of only using the bridge category when refining the selection set. Now our bridge model has been imported into Civil 3D, we can assess it in 3D, add the data to plans, and project the components onto longitudinal profiles and cross-sections to create design drawings. When projecting to views, Civil 3D will automatically add labelling of those components. In Revit, all we must do to import the bridge model is go to Add-ins and click on Import Civil Structures. Here, we need to navigate to the IMX file we created previously. Revit reads the bridge components as categories just like it would a structural column. The bridge components can host reinforcement bars and be included in section and plan views for drawing production. For tip 4, I'm going to show you how to add design models to an InfraWorks file, creating an all-encompassing federated model. We're going to start by importing a corridor model created in Civil 3D into our InfraWorks model. In InfraWorks, go to the Manage tab and select Data Sources. The file types supported by InfraWorks are 3ds Max models, .dwg from AutoCAD and Civil 3D, .imx files, Revit projects, CityGML, DGN, IFC, LandXML, point clouds, raster images, spatial data files, GIS shapefiles, SQLite databases, and SketchUp files. For our example, we're going to import a Civil 3D.dwg. Now we need to select what Civil 3D elements we want to import. In this case, we only need the road corridor. Once added, if we refresh the model via the Data Sources browser, it will then appear in our 3D model. Now visible, we can change the aesthetics of our corridor by mapping Civil 3D elements to InfraWorks materials. For tip 5, I'm going to demonstrate how to quickly assess your road designs by viewing them in profile and cross-sectional projections. Firstly, select the road, right-click and go to Show Stations in Profile View. With active tracking, we can relate the location in the profile to the 3D model. Now, let's take a look at our road as cross-sectional views. Here, we can see the geometry change and update as we scroll through the road alignment stations. If we change this to the super elevation view, we can see how the proposed road interacts with the existing topography. Finally, if we change this to the cut and fill areas view, we can analyse the sections that require material excavation and removal, and where additional material will need to be supplied. By using the Materials Quantity tool, we can instantly assess and estimate how much material is required even before we produce a further detailed design in Civil 3D. This report can be exported into a spreadsheet. Here, it shows us different lengths and volumes depending on the various components that make up the road. Now that we've created our proposed design, InfraWorks has the ability to test and assess this using the Traffic Simulation tool. First, go to the Analyze tab and select Traffic Simulation. Next, we must define our area of interest. Like always in InfraWorks, double-click to end the command once the area is complete. Once the area has been defined, you can click on the Run Simulation button. Now that the simulation has buffered, we can run an animation showing the vehicles in progress for analysis and visualization purposes. The simulation should identify any bottlenecks in the road network. This can be run at different capacities and at different times of the day. From the simulation, we can export a report for a full analysis. If we select vehicles on a short morning, we can view the drive times and the number of trips that were made. For tip 7, I'm going to show you how dramatic effects can help demonstrate project visuals to customers and clients using the InfraWorks Atmospheric Effects tool. Here, we have a view of our proposed design. If I go to Manage, Display and select Sun and Sky, I'm able to control the lighting, look and feel of the model. By amending the time and date, I can control the sun's position and light intensity. I can also control the wind direction, wind speed and cloud cover. This is a really useful tool for creating interesting effects for rendered demonstration videos in a very efficient and cost-effective approach. For flood defense schemes and assessing areas of land adjacent to water, InfraWorks users can harness the power of its flood simulation tools. In tip 8, I'm going to demonstrate how the watershed tool works inside of InfraWorks. By going to the Analyze tab and selecting Watershed, we can identify an area where we want to simulate our flood model. Once identified, we can press Enter on the keyboard, initializing the analysis of our selected location. InfraWorks then adds a map of where flooding would occur due to the topographic elevations and input parameters. As you can see, we may have gone slightly over the top with our inputs, so let's try reducing the stream threshold. Now we have reduced our model inputs, we can see that the area of flooding has decreased dramatically since our previous run. This tool goes beyond construction geometry and demonstrates InfraWorks' versatility and discipline crossovers to more geographical and GIS specialisms. In this webinar, we've discussed how InfraWorks is a powerful stakeholder engagement tool. Tip 9 is going to demonstrate how simply you can produce videos presenting proposed designs for customers and clients. First, go to the Present Share tab and select Storyboard Creator. This opens all the tools you'll need for creating visual outputs. We're going to start by creating an orbit animation. The tool uses the current view of the model. If we press play, we can see the animation in action. This can be adjusted by amending the angle and duration parameters. You should already be getting a feel for how easy it is to present your designs via InfraWorks. I'm now going to demonstrate a camera path animation which is particularly suited for linear assets such as roads, rail tracks, and defence structures. We simply need to take snapshots along the path of our proposed asset, and InfraWorks will do the hard work by linking those stills into a smooth transitional flyover. When we play the animation, we can review how well our snapshots link together. Combined with the traffic simulation and atmospheric effects tools, you can start to understand how much control you have over your outputted videos. All of this can be created in a matter of minutes, and you can have a video prepared for your customers and clients in less than 1 hour. Once we are happy with the animation, we can export this as a video. We can select the encoder type, file name and destination, and the video's frame rate. Also, the screen resolution and specific timeframes. And there we have it, a quick overview of video creation from InfraWorks. And finally, last but not least, we're on to our final top tip for an introduction to InfraWorks, looking at creating concept drainage designs for use within Civil 3D and storm and sanitary analysis software. We can start by going to the Create tab, Drainage, and selecting Drainage Network. The Create Drainage Network dialog box will appear. If we right-click, an additional toolbar will be displayed. Here, we can decide whether we want to add inlets and pipelines, manholes and pipelines, outfalls and pipelines, inlets only, manholes only, and outfalls only. We're going to begin by using inlets and pipelines. Simply click where you want the first inlet to be positioned. We can type in the dimensions so that the gullies will be evenly spaced along the drainage run. I'm now going to change the tool to add in a manhole. The drainage network follows the topography where the components are placed. As we can see, InfraWorks models gully gratings and access chamber covers for enhanced visualization. We can review the properties and swap out different parts by selecting the drainage network components. We're going to change the entire drainage run by using the Size Drainage Network tool. Here, we can change the depth of the pipework, material of the pipes, and apply rainfall data by changing the annual exceedance probability, or AEP. I'm going to change the pipework material from concrete to high-density polyethylene. Additionally, I'm going to also amend the AEP to a 1 in 10 year event. The drainage network has now updated to suit the input parameters for material and AEP. And that concludes this webinar on top 10 tips for the Autodesk AEC collection, an introduction to InfraWorks. I hope you found it useful and come away with more of an understanding of where and how InfraWorks can be applied across different disciplines and sectors.
Okay, fantastic. Thank you so much, Jonathan, for that video, for that top 10 tips. Very, very informative. Absolutely amazing to see what InfraWorks can do. I think also we'll jump straight into questions, but I don't have anything at the moment. If anybody does have any questions, please just put them into the chat or into the Q&A box so we can answer them. Um, I think you've stumped everyone.
Yeah, it was quite a lot of information to take in quite a short space of time. I suppose from what we wanted to achieve with this was to give you a general overview of actually how broad InfraWorks can be and actually where it can be used for.
Yeah, so the visualization capabilities are amazing on there for, like you said, for videos and also end client presentations. Um, One question we've got from John, how do we integrate Revit into that? I know we did a lot of Civil 3D and InfraWorks interoperability. So Revit works in the same way, I believe. You just export the I've forgotten the
The
file,
IMX file, yeah,
IMX
sure.
file.
So, generally speaking, it depends on how you're going to use Revit. So, if you've created a .rvt Revit project, you can simply import that back into InfraWorks and actually position it either by coordinate systems or simply just placing it where in a rough location of, if you've got a Revit structure, let's say, of a building. You can easily place that anywhere in the world for where you want your project to be located. It's, I suppose, dependent on if you want the topography. I believe you can export the LiDAR data that's contained within InfraWorks into Revit so that you have an existing surface. If that isn't possible, you can most certainly do it via Civil 3D.
Yeah, so Civil 3D, for Civil 3D into Revit, you mean? So InfraWorks, Civil 3D, then Revit.
Yes, so it would be InfraWorks, Civil 3D, then Revit for the topography. I see we've got some questions on the accuracy of ground levels. I believe I would say it's a very preliminary design for your existing topography. So, for example, I think the LiDAR data that's contained within InfraWorks, number one, it's LiDAR data, so there is a certain accuracy restriction there. It's also on about a 2 meter grid. So if your project is quite refined, you would probably still need to go out and do a proper survey for more detailed design as the project progresses.
Yeah, no, perfect. Question again, I think focus on sort of Revit models. So how simple is it aligning Revit building models into InfraWorks? And also, will InfraWorks honor the Revit shared coordinates?
Yes, so if Revit has a shared coordinate system, and that's all been sorted in your Revit model, you won't need to, you can import Revit in two different ways. Like I say, you can manually insert it, or you can ensure that Revit's in the right place in the Revit model, and then when you import that into InfraWorks, it should automatically locate in the right place.
Okay, perfect. So do you think the workflow for InfraWorks, where does it fit in into a workflow you would normally uh, import the Revit building into InfraWorks, or would you go the other way around? Is it just both ways? Um,
Um, Dependent on the project type, I guess. So, where for a structural project, I would be simply using InfraWorks to put the project into some sort of context. So, if you have a building, let's say, you would be bringing a Revit model into InfraWorks and then being able to have all the kind of model components, the surrounding buildings and existing roads already there, modeled in InfraWorks for you to produce any visualizations from that.
okay, so it's the kind of the end step.
Yeah, so the way I see InfraWorks is the preliminary, you've got a existing topography, things like that at the early stages of a project. And then also you can use it for end user requirements. So actually, once you've done your detailed design, you can do your traffic analysis from that. You can do your flood analysis of a project, just systems like that, essentially.
Yep. So just a question again on from Jeff again. I presume levels can be adjusted in InfraWorks to accurate site levels. I think it's the same sort of to basically match the Revit levels that you've got.
Yeah, so I mean, as I say, the existing InfraWorks model, it can be set to different coordinate systems of whatsoever it's set to originally. The accuracy of the topography is what it is as it's LiDAR, but you can bring more accurate survey data into InfraWorks if you want to. So if you've got a more accurate surface that you've created from a survey or something, you can then bring that into InfraWorks to make it more accurate, essentially.
Okay, perfect. So just a question, we talked about Revit a little bit, and we also mentioned recap. So how does that allow, so the import and export of recap models into InfraWorks or the other way around?
So it would simply be an import. So it would be federating your point cloud model from recap into your InfraWorks model. Sorry, I do believe that it was mentioned at the beginning, but it's something that we didn't touch on. It's something we could definitely look at, but I know for
Yeah,
certain you can use a Autodesk, I think it's a .rcp file within a InfraWorks model,
yeah.
and if the coordinate system's all correct in the recap model, it's a simple insert
Insert of all your cloud of your point cloud data into.
into the
Would you
InfraWorks
would you
model.
see that happening straight to InfraWorks? Or would you say bring it into something else like Revit, create service?
It wouldn't need to. You could literally do it from your recap model into InfraWorks. It wouldn't need to bypass any other pieces of software
Okay,
because you would have
fantastic.
processed that within the recap software
We've already done
itself.
that already. Yep. So a question from Luke: is the topo already integrated into the software, or is this something you'll have to align yourself?
No, it's quite nice actually. So especially within the UK, most of the UK has a lidar point cloud essentially. And I believe Google Maps will use a certain similar tool whereby actually it will automatically have a certain amount of elevations. So like I said before, I believe the LiDAR's on a 2 meter grid. So it's not the most accurate in the world, but it's a real nice starter for 10, especially when you want to start designing before any of the surveys have been done.
Yeah. Okay, great. So it's a real nice tool. The I've got a question from Jeremy, just backing onto detailed topo surveys into the InfraWorks model workspace. How would you integrate these survey models into InfraWorks?
So mainly these would need to be processed within a design one of your design software. So something like Civil 3D,
Okay,
you would essentially create your Civil 3D surface and then bring that Civil 3D surface into the InfraWorks model.
okay. So yeah, there's an extra slight step, but then it's better that way because it'll be processed properly. So would you do that in Revit as well, do you reckon?
Again, I mean, personally, with topography and survey information, it's all about using the correct tool for or the best tool for the
Yeah,
process. So I
definitely.
would always suggest Civil 3D is
Yeah,
that tool.
I think Civil 3D is with InfraWorks in the AEC collection. So you should be able to use all three of those tools really in the
Uh,
one collection. Yeah.
I suppose one point from my perspective was I was very impressed with the integration now with BIM 360 with using Civil 3D, Revit, and InfraWorks itself,
Yeah.
and actually how interoperable all those pieces of software now are.
Yeah, that's very true. When you see it with BIM 360. And also I like to use the desktop connector as well to show how easy it is to be able to access those um, everything in the one over folder structure that you have on the cloud. So that was very handy. So question again, just to finish off with a few of these. I've got a question specifically from Kieran, and I think Kieran, we may need to look into your particular issue with your models. He's asked there was a problem with uh, setting coordinate systems in InfraWorks 2021. He had a problem changing the coordinates from LL84 to OSG B36 within InfraWorks. When you
Okay.
imported InfraWorks models into the Civil 3D, the coordinates were not recognized. I'm not sure if that's specifically to your model, Kieran. I don't know if you want to have answer to that, or we can probably look into it in more detail for you. Do you think you need more detail than that, John?
Yeah, I suppose I'm just trying to compute the problem.
Yeah, I think if you've never come across something that happened, okay, happening.
No, but
Yeah,
I must confess I haven't had to do any coordinate system transformation. I've
yeah.
always used data that was always created in one coordinate system for the particular demonstrations I've done with InfraWorks. So it's certainly something I can take away and look at is using WGS84
See,
for
there's
example.
problem with previous version of InfraWorks.
Uh,
I tell you what, Kieran, if you give us an email, support@cadpoint.co.uk, we can probably look into this for you with you. We want to see if it's particularly the models that you are using, or we can have a look into it and come back to you on that with a more detailed answer. Just to finish off, then we've got a few last questions. Can Entourage be added to the base InfraWorks model without adding additional roads like cars and street furniture?
oh yes, it most certainly can. So Um, when I was discussing in the webinar about the difference between a component road and a planning road, um, by default, all the roads that are created in InfraWorks are a planning road, which is just a simplistic, here's a road along an alignment that follows the topography. But you can easily change the aesthetics to a motorway or a road with pavements, etc. What you can do with the simulation tool without producing any new roads is select an area of existing road infrastructure, and what that will do is convert it to a component road, which then means you can add any kind of road simulation into a existing conditions model
Okay.
without the need for proposed design elements.
Yeah, and this is the last question we're going to finish on. I think I was going to answer it as well. When is a so you said you mentioned that everything's kind of geared at the moment towards a US uh, type of library. When is the UK library going to be available for the Entourage?
Okay, wouldn't put a time frame on it. I'll be honest, I wouldn't know myself. The one thing that I was doing when I was playing around with InfraWorks was I think it's steps. So what they have included is things like the bridge design. They have a UK roads and bridges design manual. It follows that. I think the next stage will be the actual kind of little components. So when we were adding in construction plans and things like that, those are the things that are still lagging behind from what I've noticed.
I
Um,
see.
but with like I say, with Inventor you can customize any component you like. If you have a Revit library of items, these can be or DWGs, these can be brought into Inventor and then with that be brought into InfraWorks. But that might not be the best workflow. You might be better off doing any of your design for, unless it's conceptual. If your detailed design model requires these kind of things, put them into your Revit model or Civil 3D model and then bring them into InfraWorks. Either
Yeah,
way, there is a workaround for it. But
yeah.
to answer the question, I don't know when, if or when the UK component library will be made.
You're better off doing it through the Revit or Civil 3 anyway, so you've got more control over it, I guess, and you're already using them within your models
Yeah, I suppose
anyway.
it depends on the frequency of how often you use certain components within projects. If it's a kind of repeat components, it's probably worth creating a InfraWorks library of them. And I'm sure there's libraries, there's off-the-shelf Inventor components out there of UK objects, which then simply means you download those and bring them into your InfraWorks model.
Okay, perfect. I've just, I think we'll probably end there with the questions. If you have any more questions, please do email us, support@cadpoint.co.uk. Myself or Jonathan will be happy to get back to you as soon as we can with some more detailed answers about that. Just want to go through a few more future events that are happening, to just let you know. Look out for emails to register for other webinars. We will be announcing them soon. You will get an email once this recorded webinar is published online. You'll be able to review it and have a look at it again. So we'll send you an email about that. Just to let you know, on Wednesday, the 14th of October at 11 a.m., we've got another webinar, What's New in Revit 2021. So our architectural technologist, BIM manager Jonathan Reinhardt, will provide you with a summary of the most significant enhancements that have happened between this year and last year. So stuff like slanted walls and curtain walls, generative design is a big one, PDF and image linking, and customized Revit workspaces. So all this stuff will be covered in more detail on Wednesday the 14th. Please do sign up and register to that. I've put links in the chat. Also, we've got another one going on 2 weeks after that, October the 28th, an introduction to Navisworks for construction collaboration. So in this webinar, again, we've got Jonathan who will cover how to get to grips with Navisworks. So including creating 4D videos for construction process, clash detection between disciplines, and quality checking of your BIM models. So that would be very handy. Please sign up to that as well if you want to find out more. I think we're okay with that. I think we'll probably end it there. Thank you so much, Jonathan, for being here and introducing us to InfraWorks in such a lovely way. And very, very informative. Appreciate everybody coming to have a look at that. And yeah, so we'll probably end it there. Hope you have a nice rest of the week and a weekend.
Okay, thank you very much.
Thank you.
It was a pleasure.
Thanks very much. Take care now.